All right, so today we're going to go over 14.2, which is all about finding limits algebraically. So in 14.1, we learned what a limit was, and we learned how you could find a limit using a table or a graph. Today we're going to talk about how we could find it algebraically without having to go to our calculators, look at a table, look at a graph, etc. So when we are doing it algebraically, we have all of these algebraic properties. You guys can look through it. Essentially, the idea is we're going to plug c into the function, right? So if we're finding the limit as x is approaching c of f of x, we're going to plug c into the function. Well, if this is just a number, like for example, the limit as x is approaching 1 of 5, well, there's nowhere for me to plug the 1 into, so my answer would just be 5, right? So something like that. This one is saying the limit as x is approaching c and it's just x. Well, if I plug c in for x, of course I'm going to get c out. This is just saying if we had sum, we could split up the sums. We could split up the differences. We're not going to really do that. Same thing here. If it's multiplication, we could split it up. Really, we're just going to focus on plugging into f of x. Now remember, if we had something when we did a table, and we had tables of values like, I don't know, something like this, and this guy was an error. It didn't really matter that it was an error, right? We still looked at what is happening as we get closer and closer. The fact that this was an error didn't affect our problem. That same thing might occur. And if something like that happens, if we get an error in math, sometimes that might look like 0 over 0 or 4 over 0, right? That's undefined, which is an error. So if we get something like that, we're probably going to have to factor. Okay, so those are kind of the main ideas here. So let's go ahead and take a look at some examples. So example 1 says, find the limit as x is approaching 3 of 5. Well, I'm going to plug 3 in. Well, there's nowhere to plug it in, so my answer is just 5. I'm going to take as x is approaching negative 2, I'm going to plug that in for x. Well, when I plug that in for x there, I get out negative 2. As x is approaching negative 3, well, I'm going to plug that negative 3 in for x here, so negative 3 plus 4, which just gives us 1. I'm going to plug the 2 in for the x. 2 cubed is 8, negative 32. We're going to plug the 2 in for all of these x's. So we're going to have 5 times 2 to the 4th. Minus 6 times 2 cubed plus 3 times 2 squared plus 4 times 2 minus 2. Now, if we were in class as normal, something like this could show up on a non-calculator part of your test. Next year, if you take calculus, this definitely could be on a non-calculator. Now, of course, we're in e-learning here, so I can't really enforce calculator versus non-calculator. So might as well just use our resources and use our calculator here. So if we plug this whole thing into our calculator, we end up with an answer of 50. Okay, same thing here. We're going to plug in 1 for x, so 3 times 1 minus 5, all raised to the 4th power. 3 minus 5 is negative 2. Raised to the 4th power is positive 16. Okay, remember order of operations. Multiply, subtract, then the exponent. So plug the 0 in here. 5 times 0 squared plus 8. It's the square root of that whole thing. Oops, sorry, I didn't realize you couldn't see. 0 squared is 0. 5 times 0 is 0. 0 plus 8 is 8, which simplifies to 2 root 2. Plug the 1 in here, negative 1 I should say, 5 times negative 1 cubed minus negative 1 plus 3, all to the 4/3. Sorry about that. So negative 1 to the 3rd power is negative 1. So we have 5 times negative 1 is negative 5, minus a negative will turn to plus. Negative 5 plus 1 plus 3 is negative 1. Like I said, you could use your calculator here, but here's a little math refresher for you guys. Remember that when we do this, it's like a radical, so it's negative 1. The third goes with the radical, the 4 is with the negative 1. So negative 1 to the 4th power is positive 1, and the cube root of positive 1 is positive 1. Okay, now I'm going kind of fast here, but it's just some algebra, and we got some harder problems coming up. So I'm going to keep going. So when I plug in 1 to all of those, I get 5 times 1 cubed minus 1 plus 2 all over 3 times 1 plus 4. That's going to give us 5 minus 1. 4 plus 2 gives us 6. 3 plus 4 gives us 7. So 6 over 7. Now, when we plug in 3 here, we have 3 squared minus 3 minus 6 all over 3 squared minus 9. It's going to give us 9 minus 3 minus 6 is 0. 9 minus 9 is 0. So this is an error, right? Error / undefined. But we know when we're finding limits, that doesn't matter. That doesn't mean our answer is the limit does not exist. That just means that there's a hole, right? And we need to figure out, well, what is the y value of that hole so that we can know what is it approaching. The fact that it's an error doesn't matter. So what we're going to have to do here is factor. We're going to have to factor, our favorite thing. So what multiplies to negative 6 and adds to negative 1 would be negative 3 and positive 2. This is the difference of perfect squares, so minus 3 and plus 3. Well, if you look at that, we have a hole, right? We have the same factor on top and bottom. So now that those go away, now I can plug 3 in here, right? So we have 3 plus 2 over 3 plus 3, which gives us 5/6. Okay, so even though when we plug it in here we get error, that doesn't matter. That just means we're going to have to factor, and our answer then ends up being 5/6. All right, number 11. So we have a piecewise function here, right? So remember, when we have something like a piecewise, it might end up looking like something like this. So maybe we have something that looks like this, and then like this, right? And remember, when we're talking about limits, if these from left and right point to different numbers, then we would say that it does not exist. So we need to figure out, at x is approaching 0, are these different numbers? Because if they're different numbers, then we would have to say they're not going to exist. So we're going to have to plug the 0 into both of them. So we're going to plug the 0 into the e to the x, and we're going to plug the 0 into the 1 minus x. So anything to the 0th power is 1. 1 minus 0 is 1. Those are the same, so our answer is 1. Now let's say we were doing like as x is approaching 1. E to the 1 is 2 point whatever. 1 minus 1 is 0. So this would be 2 point something. This would be 0. 0. Those aren't the same, so we would say does not exist. Okay, so whenever we have a piecewise function, we have to plug in this 0 into both of them. Okay. Now number 2, or 12 I should say, as x is approaching 2. When we have something like this, you could go ahead and plug the 2 in, but I'm going to tell you right now, you're going to get an error like we had in number 10. So we're going to have to factor. And remember, when we're factoring, when we have 1, 2, 3, 4 terms, we factor by grouping. So we're going to look at these first 2 terms. Well, what do they have in common? They have an x squared in common. When I factor out an x squared, that leaves us with x minus 2. The second term here, they have a 4 in common, so I can factor out a 4, which also leaves us with x minus 2. On the bottom, we can factor out an x cubed, which leaves us with an x minus 2. And then we could factor out nothing, so we're factoring out a 1, which leaves us with x minus 2. All right, remember, this is factor by grouping. So then that means that we have x squared plus 4, and then x minus 2, and then x cubed plus 1, and then x minus 2. So then we can see there's a hole at 2, so that's why they got to get crossed out there. Now we can plug in that 2 here. So we have 2 squared plus 4 over 2 cubed plus 1 gives us 4 plus 4, 8. 8 plus 1, 9. Okay. When in doubt, try to factor. Can't hurt. All right, number 13. Now it says find the limit as x is approaching 2. So we've got the limit as x is approaching 2 of the average rate of change. Now that's a fancy word of saying slope. And if you remember, slope is y minus y over x minus x. So that's exactly what we're going to do here. We're going to do f of x, that's a y, oops, minus f of, and it's saying from 3 to x. So f of 3 over x minus 3. Okay, it's like we have two ordered pairs. We have x comma f of x, and then we have 3 comma f of 3, right? So we've got y minus y, x minus x. It's just the slope, y minus y, x over x. That's what rate of change means. So now we're going to go ahead and we're going to plug these in. So f of x is right here. F of x equals x squared plus 2x. Minus f of 3. Well, f of 3 just means plug 3 in. So if I plug 3 in here, f of 3 is going to equal 3 squared plus 2 times 3, which gives us 9 plus 6, which is 15. So f of 3 is 15, all over x minus 3. Now, like I said before, when in doubt, factoring can't hurt. So let's go ahead and try and factor here. So if we tried to factor, we would have, what, x plus 5, x minus 3, all over x minus 3. So then our x minus 3's can cancel, and now we can plug 2 in. So 2 plus 5 gives us 7. Now let's say if we would have factored and these didn't cross out, that's okay. It's not the end of the world if these don't cross out, especially because this is a 2. Since this is a 2, if I do 2 minus 3 here, that's not going to give me 0, right? And the whole problem is when we have 0 here. So let's say these didn't cross out, we would still plug in 2 and we would get an answer, right? If we would have plugged in 2 here, we still would have gotten the answer of 7. It's just always nice to factor. It makes things a little easier. And sometimes you don't want to go through all the work of, if we would have plugged in 2 here, that would have taken a lot of work. It was faster just to resort to factoring right away. Okay, so I always resort to factoring. Sometimes you need it, sometimes you don't, but that way I'm just always doing the same thing. Now 14 says let x approach c. So let x approach c for the function 1 over x cubed. And then it says c is 1. Well, if c is 1, let's put 1 here. c is 1. So I'm finding the limit as x is approaching 1 of 1 over x cubed. So 1 over 1 to the third is 1. And that is all of 14.2.